Welcome back. This is Nagarajan, working as an assistant professor in the Department of Electrical and Electronics Engineering in MAM School of Engineering, accredited by NAC, approved by AICT New Delhi, affiliated to Anna University, Chennai. So, in the previous class, we discussed about the differential amplifier and its application. So today we are going to discuss about one of the that is one of the connection of operational amplifier, which is serves in the instrumentation, which is very important, and that is instrumentation amplifier. That is instrumentation amplifier. Okay, so in this instrumentation amplifier, very important points to be discussed. We are going to discussing about the important points. First, instrumentation amplifier. Okay, so instrumentation amplifier is one of the type of differential amplifier that has been outfitted with input buffer amplifier, which eliminates the need of impedance matching and thus makes the amplifier particularly suitable for the use of measurement and test equipment. Okay, so this point represents it. This indicates that an operational, that is a differential amplifier, cannot be connected directly to any measuring instruments. Okay, because that will measure the input with reference to the ground. Very important point is with reference to the ground. So whatever the value it is showing, whatever the value it is we are getting at the output, V out, is with reference to the ground. But with reference to the ground, that is the output that whatever is getting is almost that is not correct value. It is nearer to the correct, but it is not exactly the accurate value. So we have to take the accurate values. Okay, that is, it should differentiate the noise and the biosignal. So in this point of view, we need to provide an impedance matching and buffer circuit. Okay, so when an impedance matching circuit, buffer circuit, okay, that is the differential amplifier circuit with buffer circuit is called as instrumentation amplifier. Additional characteristics include very low DC offset, low drift, low noise. Okay, so these are the points. These are the important characteristics of the operational amplifier. Okay. Next, again we will have a small point-wise discussion. Okay, an instrumentation amplifier is a differential amplifier which meets certain industrial standard requirements. Okay. They are, first one, precise low level signal amplification. Okay, even a very low level, that is low level signals can be amplified using this instrumentation amplifier. It is low noise. Okay, it is immune to the noises, especially very even low noises, and it is good thermal drift response. Okay, good thermal drift response here the means it won't respond to the thermal drift. Okay, it won't respond for the thermal. That is, even though the junction is getting overheated, it will operate in the safe operating region. Okay. Then high input resistance. Okay, and accurate closed loop gain and easier gain adjustment. Okay, the output is very accurate since it is a closed loop circuit, and the gain can also be adjusted. Okay, that thing we will see in the circuit. Low power dissipation, and finally high common mode ratio. If there is a low thermal drift, then slew rate must be higher. Okay, the response to the uh, fluctuations, the response to the EMI, that is will be very low. Okay, next. Now we are going to discuss about this instrumentation amplifier. Okay, so here we can see that there is a differential circuit. Okay, there is a differential circuit and buffer circuit. This is one buffer circuit and this is another buffer circuit. Okay, and one operation, that is one differential circuit. So the differential circuit, one disadvantage is the order of change, that gain. Two pair of resistors need to be changed. Finally, what does it mean? The resistance value and the operational amplifier must be the same. Okay, if you want to change the output, then the resistance value has to be changed. So for that, they can provide a variable resistance, okay, to overcome the effects. Next one is the more common differential amplifier in which the gain can be adjusted using the resistor RG. Okay, so the first point, the disadvantage is given. The remedy for the first point is given in the second line. So how the resistors can be changed, that is the adjustable resistors by RG. So the outputs, here the V in is the input and V2 is the another input, and R1 were common and bufferly connected. R2 is also the common one. R3 is also the common one. Therefore the RG is the variable one and output V out. Okay, then the V out is equal to 1 plus 2 R1 divided by RG into R3 divided by R2. Okay, the whole multiple by V2 minus V1. Okay, so this is the output equation for the differential amplifier. Okay, so whenever there is a necessity of connecting differential amplifier, then if the system has to be made reliable and the output should be accurate, then we can connect this instrumentation amplifier by replacing the differential amplifier if there is a dual input, and if there is a single input, then this differential amplifier is enough. Okay. So I hope this session might be useful for you, that clearly understood the instrumentation amplifier. So in the next class we will discuss about the chopper amplifier. Thank you.